Hello guys, let us do some numerical problems. In the first one, I'm going to take such a problem where we can calculate almost all the quantities like angular velocity or angular displacement, tangential acceleration, centripetal acceleration and all that. Let us take this example of minute hand of a clock. So let us calculate angular velocity. Okay, and length of this hand, it can be anything, but let us say we take it 16 centimeter. Okay, so if this is our clock and this is the center, this is that hand 16 centimeter long, this is my 3, 12, 6 and 9 here. Now for a minute hand, how much time does it take to complete one rotation? It takes 60 minutes. So time for one complete rotation is equal to, let us call it capital T. We can take T as time period. What is time period? Time period is the time taken to complete one full circle, and that time is 60 minutes. So obviously minutes is not an SI unit. Let us convert that into seconds. So that would be 60 into 60, that is 3600 seconds. What's the angle described? Angle described is equal to 360 degrees, and 360 degrees is 2 pi radian. So angular displacement in 1 hour or in that much time, that is equal to 2 pi radian. So my angular velocity, therefore my omega, that is angular velocity, that is equal to my angular displacement upon time. So that would be equal to 2 pi upon 3600 radian per second. So that is my angular velocity. So now we have found out the angular displacement, angular velocity. Now what about angular acceleration? When would angular acceleration be? It would be there if my angular velocity changes with time. But does it change for a clock? No, it's not a ceiling fan wherein you just turn the switch on. The fan starts from a speed of 0 and after some time it attains its maximum speed and keeps on rotating with that speed. Now if you switch it off, from maximum speed it will come back to minimum speed, that is 0. Okay, so over there will be some angular acceleration when you turn it on or turn it off. In this case there is no angular acceleration. So angular acceleration alpha over here is 0 radian per second square. So my first quantity, second quantity, third quantity, that has been calculated. Now what about radial acceleration here? This minute hand is performing uniform circular motion, so there is going to be some centripetal acceleration. So my radial or centripetal acceleration is equal to, that would be equal to v square upon r or omega square r. Now I have my angular velocity here, which I have already calculated. I also know this radius of the circle, that is the length of minute hand. So what I can do is I just substitute that here. It is 2 pi upon 3600. It is equal to pi upon 1800. So it would be pi upon 1800 squared, and then that multiplied by 16 centimeter. 16 centimeter, I have to convert that into meter, so upon 100. So whatever is the value that you can calculate with your calculators, and this quantity is, its unit is going to be equal to meter per second square. We have found out angular displacement, angular velocity, angular acceleration, which is obviously 0 here. Radial acceleration we have found out. What about tangential acceleration? Now here, in uniform circular motion, you have only centripetal acceleration. There is no tangential acceleration. Had there been tangential acceleration, then the speed would not have been uniform. The angular velocity would change, correct, at every point. So again, let me write here that my tangential acceleration is also equal to 0 meter per second square it would be. So these are the 5 quantities that we have found. We are going to have one more video on numerical, and in that video we would take this vertical circular motion as our example. Thank you so much.